Chapter 9, Attitudes. Until now, we've been looking mostly at sentences made up of a single clause. Now we're going to expand to sentences that have two clauses, where the higher clause has an attitude verb. Examples of sentences with attitude verbs include the following. John thinks the sun shines, where the attitude is thinking. It seems to Mary that things are getting better, where the attitude is seeming. Bill imagines that he will be rich someday. This is an imagining. Sue doubts global warming will stop anytime soon. This is a doubting. So the question is, how do we give an analysis to these? They look very much like predicate argument structures. So John thinks the sun shines looks like it has a verb think that takes two arguments, John and the sun shines. So it looks like perhaps what we should be doing is analyzing it exactly like it is here. Take think to translate to a predicate logic think that takes two arguments, the name John and the translation of the sun shines here. But this doesn't work. And it doesn't work because of this part, the highlighted, the sun shines. The problem is that that highlighted part is going to be given a truth value as its interpretation. If the sun shines, that's true. If the sun doesn't shine, it's false. That means that the whole sentence is going to be true if and only if the ordered pair consisting of John and some truth value is in the extension of think. Up here, it's the truth value true. Down here, it's the truth value false. But neither one of those is going to work. Neither one is an appropriate meaning for the sentence. Suppose we took the first one, okay, where we used true in here. Then it says the sentence, John thinks the sun shines, as interpreted here, translated here, is true if and only if John, true is a member of think. But what that means then is that any other sentence that puts a true sentence there should come out as true as well. So suppose, okay, we'll give examples coming up pretty soon. That is, the truth of the sentence, John thinks that S is going to be dependent entirely on whether S is true or false. It has nothing to do with whether John thinks it is. The same thing will happen if we use false instead of true here. Almost the same. The only difference being now we get everything to come out as true whenever you put a false sentence translation in there. Okay. Now, suppose that John thinks the sun shines is true. Does it follow that John thinks that 2 squared equals 4 is true? Well, if the sun actually shines, then that should follow, but it doesn't intuitively. Does it follow that John thinks that 2 squared is 5 is true? Well, if the sun doesn't shine, that's predicted to be true. But neither of these follow no matter what is happening with the sun. John's thoughts about the sun shining and his thoughts about these mathematical equations are just unrelated. And yet with the analysis that I outlined above, one that takes think to take these two arguments, it's predicted that these should follow. Okay, so we need to do something different. Our solution is going to be to add possible worlds here just similarly to how we did in the last two chapters, but we're going to do that in a little bit of a different way. We're going to take a sentence to translate into something true or false of a world. Okay, just like we said that predicates before have extensions that differ from world to world, we're going to say full sentences denote propositions that have truth values that differ from world to world. So rather than our old analysis, it took John Smiles to simply have this kind of a structure. We're going to take our new analysis to give it a more complicated structure. It's going to be a function from worlds to formulas. In this case, to the formula Smile W John. So we're going to have to make changes to our basic expressions. Some of them we've already seen. So shine is going to be like smile, which is going to be like win. It's going to be a one-place predicate with an extra argument for worlds added to the front. Lambda W, lambda X, shine WX. Saying that X, this means essentially X shines in world W. Okay. I've added an S to my lambda W to indicate that this is now a world variable, which is a different semantic type. It's not an individual, it's not a truth value, it's a world. Okay. And we're going to do the same thing for our other two-place predicates. C is an example. We essentially add in a world argument, same with give, add in a world argument, and bind that world argument out here with a lambda S, lambda W, I'm sorry. Okay. We're going to do something very similar to John, to a name. We just go ahead and throw on a lambda W at the front and we say John of W. But there is a difference between the predicates up here, these, and the names like John. Okay. And the difference is this. Predicates can have different values at different worlds. If you want to know what the value of shine is at the actual world, you look at things that actually shine. That's going to be, you're going to have a predicate that's true of those objects. If you look at the next world, maybe some of the things that actually shine in the real world don't shine in that world. Okay, so that predicate is not going to be true of those things at that world. But with names, we never give different values at different worlds. For the name John, no matter what two worlds you pick, W and W prime, the interpretation of John at W is going to be identical to the interpretation of John at W prime. Essentially, this is our way of saying that a name picks out an individual and it gives us the same individual at every possible world. With determiners and quantifiers, we're going to do something a little bit different. These don't start off with lambda W. They do contain a lambda W in the middle. One here, but they start off saying, give me one of these. What is that? That's a property expression. It's a function that takes a world and gives back a function from individuals to truth values. In short, this is our new kind of denotation for words like smile and shine. Okay, so this says, give us one of those kinds of things. It'll also include things like man and table. Okay, and then I'll give you back something that starts with a lambda W. Okay. So we're going to need new rules. Just by changing the analysis of the words, we have to change how they go together as well. On our old analysis, we took a sentence like John smiles, and we broke it down into pieces. It had a function part, smiles, and it had an argument part, John. The function, lambda x, smile of x. The argument, the name John. And we simply took the name John and substituted for that variable that's being lambda bound here. We give back smile John. Okay, that's pretty familiar by now. We can't do the same thing in our new analysis. With the types that we've given, if we try the same thing, this is what happens. I put shine in here by accident. That's supposed to be smile. Ignore that. The rest is right. Okay, so the analysis of smiles is supposed to be lambda w, lambda x, smile wx. That says find a world, something that can act as a world that can go into this position and find it out here. But this expression, whatever it is not a world. It's a function from worlds to individuals in this case. It has a type, its type is SE. Its type is not S. This requires type S. So we can't take this and plug it in for the world variable here. We get something instead that is undefined. So we're going to create a new rule that goes like this. It's based on our old rule. Our old rule told us how to combine a sigma tau type of a thing with a sigma type of a thing. Our new rule tells us what to do when we have a lambda w in the front of all that. We have a function from worlds to that kind of a thing. And we have a function from worlds here to this kind of a thing. Okay. So if A is some expression of this, higher this type here, and B is some expression of this type, we're going to combine them, and order again doesn't matter, combining A and B or B and A, to give us the following. We're going to add a new lambda variable, lambda w prime. We apply the interpretation of A, translation of A to w prime. And that result applies to what we get when we apply B, the translation of B to w prime. Okay, so this looks very similar to what we did with predicate modification before. With predicate modification, we had a lambda z out here. We put a z here. We put a z here. But instead of taking this as a function and applying it to this as an argument, instead we put an and in between the two and said, and we can join them, okay? But it's the same basic idea that we're adding a new lambda binder here. We're giving new arguments here and here, and we're doing something with the result, okay? So if we do John smiles, it works like this. Just following this pattern, we put smiles in place of A and John in place of B, and that gives us this. And smiles is here. That's the interpretation of smile, the translation of smiles, okay? The translation of John is here. And now we do our lambda conversion the same way we always do. We take this function, we apply it to this argument. That means this one, the W prime, has to substitute for the W here. That gives us the result, lambda x, smile W prime of x. Okay. I've made a mistake here, so I want to see if I can fix my mistake. Okay. For the next one, we have lambda W John, and this should have been lambda W John of W. Okay, that was my mistake. And that means that instead of John down here, this should be John of W, John of W prime. Okay. And that means that here we end up with lambda W prime, smile W prime, John of W prime. Okay. Now, we said that it doesn't really matter what world you give to a name, it'll always pick out the same thing. And so you might think that having the world as an argument for John is really not necessary. But it'll make our life a little bit more uniform. We can do multiple things in the same way by doing it this way. Now, once again, I've forgotten my W here, my W prime on John. But I want to focus on a different problem here. That is that we now have the translation of the sentence, John smiles, being a function. Now, function isn't truth values, it's a function. It's that function f such that for any world W, f of W is true if and only if the pair W and John is a member of the interpretation of smile. Okay, that doesn't tell us the same thing that we get before. Before we said that the sentence was true if and only if John was a member of smile. But we're going to get essentially the same thing by taking this function, this f, and applying it to the actual world. That then gives us something true if and only if the pair made up of the actual world and John is a member of the denotation of smile. Okay, so I said we wanted to add worlds, and we wanted to add worlds in order to do a better job with think. So let's go back to think and give a first attempt at an analysis of this word. So our first attempt, we're going to change it, is this. It says think takes a P of type ST. That is, it takes something like the sun shines or Mary smiles, something that is a function from worlds to truth values. And it plugs that thing into here. It's going to give us back a lambda W, lambda X, think WXP. And we're going to take this part, think WXP, to tell us that the individual X has a thought in the world W, and that thought is P. Okay, now, finally, I started doing my names properly. I have John of W the way I wanted to have it originally. So from this point, hopefully we won't have that mistake again. And now we go ahead and give an analysis of John thinks the sun shines. John thinks the sun shines is going to have two pieces. One of them is John. One of them is thinks the sun shines. And both of them are going to be lambda W expressions. Thinks the sun shines has think, that's here, applied to the sun shines, that's going to be our P. And so it's going to end up as something of this form, where P is filled in by the meaning of the sun shines. Okay. So we use our intentional function application. Give it a new variable, take the thinks the sun shines to apply of that variable, take the translation of John to apply to that variable. Combine the two by function application. So I'm going to do this. I'm not going to go into the full detail of the translation. The full detail is given in the text, but I'll go through the outline of the translation. Here's thinks. And thinks, we said, has to combine with the translation of the sun shines. That's our P argument. Okay. This whole thing is just a substitution for this. Okay. This one does not use intentional function application. It's just normal function application. This is our function. This is its argument. Okay, and it'll combine the same way we did in all of the last several chapters. The translation of John is given here, lambda W John of W. It's going to have to apply to our W prime argument. I've done that lambda conversion here. We take W prime, we substitute for W, and we get back John of W prime. Okay. The rest on this page I've just left unchanged. Okay. So the next thing we'll have to do is figure out what the translation is of the sun shines. And again, this one is done in detail in the text. I'm just going to give you the result. The result is this, lambda W, shine in W, the Z, such that Z is sun in W. Okay. The translation of thinks, we've already given on the previous page. That's this. The translation of the sun shines, we just gave. That's this. And then this part here, we just copy right here. Okay. So this is now what we have to calculate. It looks a lot more complicated than things we've done in the past, but it's mechanical. You do things in the same way. Here we have an expression that has to combine with an argument. The expression says find something that can substitute for P, and this is what you get. Put it in place of P. Okay. You'll get back something that's going to be lambda W and the result of that substitution. That's going to apply to a W prime. That W prime will substitute for all the occurrences of W. We've got one here, we're going to have one here, we're going to have one here. Sorry, change that. It's going to substitute for the occurrences of W that are bound here. The only one there is this, W. W prime will then fill in this W. The result of that is here. Is lambda X, think W prime, that was a substituted W, X, and then we just give that thing that's substituted for P. That is the meaning of the sun shines. This part just gets carried over from before. Now we once again have a function with a lambda x here. Is this whole thing. Sorry, it goes a little bit further. And it takes an argument. This is the argument. Okay, so we have to take that argument and substitute it for any occurrences of x inside of here. We only have one occurrence of x, that's right here. So we take our John of W prime and we just throw it right into that position. And we get this. Okay. And we've decided that this is going to be interpreted as true of a world, like true of the actual world, if and only if John in that world has a thought in that world, which is this thought, the thought that the sun shines. Okay, so that's a basic analysis of think. It tells us think WXP is true if and only if P is a thought in X's head at world W. Now I want to look at an example that shows us we need to change that a little bit. The situation is this. Last week, John told me that Mary is a professor. Just now, John told me that all professors are on campus. In this situation, I can truthfully tell somebody, John thinks Mary is on campus. And it doesn't really matter if John has put these two thoughts together in his own head or not. Right? He has two thoughts, that Mary is a professor. He's got a thought that all professors are on campus. But unless he puts them together and draws a proper conclusion, he's not going to have the thought that Mary is on campus. Maybe he just told me all professors are on campus because he knows there's a faculty meeting and everybody is present at the faculty meeting. Okay. And that includes all of the professors. Fine. That's not a thought about Mary. It's a thought about the entire population of professors. Okay. Maybe he did, maybe he did not think that of the consequence that means Mary is on campus. Doesn't matter. This sentence, John thinks Mary is on campus, still comes out as true. The problem is that our analysis predicts that it should be false if John has not put the two together into his own Mary is on campus thought. So here's a change we're going to make. We're going to say for a sentence S, John thinks S is true if John has some thought T where T entails S. Okay? That is, T doesn't have to be exactly the same as S. It's a one-way street. If T is true, S is true. Okay. And we're going to analyze entailment like this. P entails Q if and only if for all worlds W, P of W arrow Q of W is true. What is this saying? Well, it's essentially saying that there's no world where P of W is true and Q of W is false. You can have any of the other three patterns of truth values. If P of W is true, then Q of W is true. If P of W is false, Q of W could be true, could be false, doesn't matter. You just never get P of W true and Q of W false. So that bit is being added here, okay? That's our entailment. We still have think taking a proposition, gives us something that takes a world, takes an individual, the person who's thinking, and now is where the differences start. This says that there is some T, doesn't tell us what it is, just that there's some, where T is a thought of X's in world W. And no matter what world W prime you take, if T is true of W prime, then P is also true of W prime. Okay, that's our new analysis of think. Let's see how it works here. Mary thinks, John thinks, Mary is on campus. That requires John to have some thought such that every world in which that thought is true is a world where Mary is on campus. Well, we've already given what that thought can be, kind of. The thought we're going to take to be a conjunction. It's the thought that Mary is a professor conjoined with the thought that all professors are on campus. Okay. If Mary is a professor and all professors are on campus, it follows that Mary is on campus. Every world in which Mary is a professor and all professors are on campus in that world is such that Mary is on campus in that world. So this analysis of think is going to give us a way of dealing with the case where the actual thoughts in John's head aren't identical to what I'm claiming he thinks, but they do entail what I claim he thinks. Okay, next we want to look at ambiguities in attitudes. I want to look at two different ways of understanding a sentence of the form A thinks S. The first one we just saw, it's that S follows from a thought in A's head. And I'm going to give that now a label. I'm going to call that a de dicto interpretation. Together with that, I'm going to say there's another interpretation that starts off the same. S follows from a thought in A's head, but it adds in something together with known facts about the world. And we'll see exactly how that works coming up soon, okay? I'm going to give this a different name. We're going to call this de re, a de re interpretation. The terms de re and de dicto are from Latin. Dicto has to do with saying. Re, I don't know exactly what it means. But these are the labels that people use for making a distinction. So now I want to show you why we need to make this distinction. Here's the situation. There's a certain man in a brown hat whom Ralph has seen several times under questionable circumstances. Ralph suspects he is a spy. There's also a gray-haired man known to Ralph as a pillar of the community, who Ralph is not aware of having seen except once at the beach. And I'll add, Ralph does not think that the gray-haired man is a spy, okay? But Ralph doesn't know it. The men are one and the same. Okay, now we have a question. Does Ralph think the gray-haired man is a spy? Well, we could certainly say, here are the circumstances. Ralph thinks the man in the brown hat is a spy, and he doesn't think the gray-haired man is a spy, and yet the two are the same. Looking at it that way is like saying, I'm trying to look inside his head and describe the thoughts that he has in his head. One of those is the thought, the man in a brown hat is a spy. But there isn't also a thought of the form, the man in the gray-haired man is a spy. So if we only care about what's inside of Ralph's head, our answer is no. But if we care about what Ralph's thoughts tell us about the world, that's a little bit different. So I can reason as follows instead. I can say, look, Ralph thinks the man in the brown hat is a spy. Ralph thinks the man in the brown hat is a spy, okay? But that man is the gray-haired man. So essentially, Ralph thinks the gray-haired man is a spy. He might not know that that's what he thinks, but that's what he thinks. Because the gray-haired man is the man in the brown hat. So if that's the way we think about it, then we would have to say, yes, Ralph does think the gray-haired man is a spy. So we have two different ways of thinking. They give two different answers. This suggests that perhaps the sentence has two different interpretations. Perhaps the sentence is ambiguous. Now, our analysis so far only gives us one interpretation. It gives us this. It's a property of being a world such that there's a thought in Ralph's head, and at every world, if that thought is true of the world, then the gray-haired man is a spy at that world. This is our de dicto interpretation. It says there's some thought in Ralph's head that entails that the gray-haired man is a spy. In the situation we just saw, that's false. Ralph doesn't have that kind of a thought in his head. Okay. So how do we get it to come out true? Well, we're going to give a second analysis of think, which we're going to call a de re analysis. And it's very much like the analysis that we had, except that it adds three pieces. It adds a quantifier over Q. Doesn't tell us what Q is, just says that there's some Q. Q has to be true of world W. That's ultimately going to be the actual world. That's the W that's introduced here. And that is going to stay until the end. And then we say that the sentence is true if this whole thing holds of the actual world. Okay. We're also going to add QW, Q of W prime in the entailment. So we're going to require not only that whatever thought Ralph has is true of W prime, but also that this Q, whatever it is also true of W prime. In every world where those two things hold, then whatever it is that we claimed, in this case, the gray-haired man is a spy, that's also going to be true. Okay? So here, I've spelled it out a little bit, filling in the pieces. the sentence, Ralph thinks the gray-haired man is a spy, is going to end up saying this, that there's some thought, there's some other proposition. The thought is a thought of Ralph's in world W, and the proposition is true of that same world W. And in every other possible world, if that thought is true of the possible world, and this proposition is also true of that possible world, then the gray-haired man is a spy is true of that world. Okay. Breaking that down a little bit, this is going to be true of the actual world, just in case three things are true in the actual world about a thought and a proposition Q. First, Ralph has that thought T in the actual world. That's this part. Second, the proposition is true in the actual world. That's this part. And third, the thought and the proposition together entail that the gray-haired man is a spy. That is this part, however far it goes, probably about to there. So now let's go back to our situation and ask, what could these thoughts and propositions be? We need a thought that Ralph has in the actual world. We'll take that thought to be the thought that the man in the brown hat is a spy. Okay? We need another proposition that's true in the actual world. There are many to choose from, but we're going to choose one. That is, the man in the brown hat is the gray-haired man. When you put those two together, the man in the brown hat is a spy, and the man in the brown hat is the gray-haired man. Those together entail that the gray-haired man is a spy. So this analysis gives us a true interpretation in the situation that we introduced before. Okay, now I want to turn to a little bit of a problem with names. We've been careful to take names to be different from predicates. A name always picks out the same person in every possible world. Our assumptions about names are going to cause us a little bit of a problem here. Okay, and I'll use a different example to show it. Here's a situation. Jane has a Roman history class. She's learned a lot about Cicero. She's learned very little about Tully. She doesn't know that Cicero is Tully. She says Cicero is famous. Tully is not famous. Okay. Now, if we ask whether her sentences are true or false, Cicero is famous. Okay. And since Tully is Cicero, Tully is also famous. One of them is true, one of them is false. They can't both be true because Cicero and Tully are the same person. But what about the following? Now I'm telling you about Jane. Okay, Jane has these thoughts, and I tell you, Jane thinks Cicero is famous. Well, Jane said Cicero is famous. I would say this is pretty clearly true. What about the next one? Jane thinks Tully is not famous. Well, she said Tully is not famous. That's a pretty good indication of what she's thinking. So Jane thinks Tully is not famous is also true. The next two are where the problem's going to come in. If I'm trying to describe Jane's thoughts to you, can I say Jane thinks Tully is famous? It seems the answer is no. That's not giving the right form to her thoughts. She would never say Tully is famous. And if I asked, is Tully famous? She's going to say no. So this isn't telling you the form of a thought in Jane's head. And the same is going to be true here. Suppose I tell you Jane thinks Cicero is not famous. We look up here, it says Cicero is famous. That's what she said. That's not quite the same as Cicero is not famous. It's the exact opposite. It sounds like that's not what she's got in her head. She's got in her head, you've got Tully is not famous, but Tully and Cicero are different names. So those come out as saying different things. Intuitively, that's the way we see this. So if we're trying to describe what's in Jane's head, these last two sentences here, those come out as false. The problem is that under our de dicto interpretation, all four sentences are predicted to be true. The de dicto one, remember, is the one that's supposed to tell us what's inside of a person's head, the way they are seeing the world. Okay, it gives us something that follows from what they have in their head, but it's only going on what's in their head. You're not bringing in any external facts. So the problem now is, how do we get this fixed? What we need to do is change our de dicto analysis so that A and B stay true, but C and D come out as false. Okay. So let's first see why it is that they come out as true. Here are the de dicto translations of C and D. C says you're going to be true of a world if there's some thought that Jane thinks in this world, in that world. And for every world W prime, if the thought is true of that world, then Tully of that world is famous of that world, in that world, okay? The de dicto translation of D is very similar. The only difference is that it says, in every world in which the thought is true, Cicero is not famous in that world, okay? And the thoughts in Jane's head are going to be this. We'll call this one T1. This is the Cicero is famous thought, okay? It's like all thoughts, it's a function from worlds to some truth value. T2 is the Tully is not famous thought. Those are the thoughts she has in her head. We know because she said Cicero is famous. She said Tully is not famous. Okay, the problem is, for example, that T1 is going to be true of a world W prime if and only if famous W prime Tully of W prime is true. That is, this one, let's say, this with Cicero in here is true of a world like W prime if and only if this is true with Tully in there. The sentence, Cicero is famous, is true if and only if Tully is famous. Here's why. The names Cicero and Tully both pick out the same person in the actual world. And we're assuming that a name picks out the same person at every possible world. So if Cicero picks out this person here, in the actual world, he picks out this person here in every other world. If Tully picks out this person in the actual world, because Cicero actually is Tully, then the name Tully picks out this person in every possible world. That means no matter what world we look at, Cicero at that world is the same person as Tully at that world. So if that individual is famous in a world, it doesn't really matter whether you call him Tully or if you use Cicero to pick him out. Those are the same person at that world. And so if Tully is famous in the world, Cicero is famous in that world. Now, our de dicto interpretation. Jane thinks Cicero is famous means Jane has a thought which entails that Cicero is famous. Okay. That's true. Her thought is Cicero is famous. It's basically this one with a lambda W in the front. Okay. But now Jane thinks Tully is famous is going to be true in the same way, because that same thought, a Cicero is famous thought, now entails Tully is famous. And every world, they're saying the same thing about the same person. So if one is true, so is the other. And that means that the one entails the other. We already said the sentence Jane thinks Cicero is famous is true de dicto. So we predict that Jane thinks Tully is famous should be true de dicto as well. But our intuition tells us it should be false, because Tully is famous is not something that we can get just by looking inside of Jane's head. So that is our problem. So here's our solution. We're going to separate the person that a name picks out from the meaning of the name. The fact that the name Cicero picks out the particular individual that it picks out is now not taken to be part of the meaning of the name. Instead, we're going to say that that is a fact about how the name is used. The meaning only gives us that the name picks out the same person in every world. It doesn't say who that person is. Okay? So when you look only at the meaning of the name Cicero and the meaning of the name Tully, they're actually the same. That is, they are simply, the meaning is simply that this picks out the same person at every world, but that meaning doesn't tell us which person it is. It doesn't tell us whether they pick out the same person or a different person. That's not part of the meaning. Okay, so the name Cicero, as it turns out, in the actual world, picks out the same person as Tully. But this counts as knowledge. This is not the meaning of the words. You and I, now, we have this knowledge. Jane does not. Since she does not have this knowledge, the thought that she has in her head do not entail that Tully is famous. The only relevant thought she has in her head is this. This is the thought that Cicero was famous. Okay? She does not have the thought in her head that Tully is famous. And very importantly, she does not have this piece of knowledge that Cicero is Tully. Without this piece of knowledge, what she does have in her head does not tell us that Tully is famous. It only tells us Cicero is famous. And so, by taking the name to not have as its referent as part of its meaning, we can solve this problem. In the situation we described, Jane does think de dicto that Cicero is famous, but she doesn't think de dicto that Tully is famous. Okay, the last thing I want to look at is what happens if we instead look at de re. And I want to first convince you that the de re interpretations come out different. In particular, the de re interpretations of C and D come out true. So here's the situation. I'm only going to look at C. D does the same thing, but I don't have time to do both. In C, Jane thinks Cicero is famous and Tully is not famous. We know because she said so. You and I know, but Jane does not, that Cicero is Tully. She thinks Cicero is famous. And since she thinks Cicero is famous, since Cicero is Tully, it follows that she thinks Tully is famous. But we already said she thinks that Tully is not famous. So clearly, one of her original thoughts has to be wrong. Okay? This is a way a philosopher might make an argument. In the middle of the argument, we have sentence C. She, Jane, thinks Tully is famous. It was a conclusion that we drew from a thought she has in her head, Cicero is famous, and a fact about the world, Cicero is Tully. This is one of the ways we use sentences like this. Okay? So it is possible to use it in the same situation we did before and for it to be true. We get that by giving it a de re analysis. We use the de re analysis of think that we had before, which was just like the de dicto analysis, except it adds a new proposition here, here, and here. And what we need to think of are these possible values for T and for Q. Suppose we take T to be the thought. I can't highlight the thought. It's this thought, and I get started, and it keeps on going to, and it doesn't highlight. The thought that Cicero is famous. That is a thought in Jane's head, right? She says Cicero is famous. Presumably, she has that thought. Our extra proposition, Q, is not in her head, but it's true. Cicero is Tully. This tells us it's going to have to be true of whatever world we're talking about. And in the end, that's going to be the actual world. So Q has to be true of the actual world. That means that Cicero in the actual world has to equal Tully in the actual world. Okay. Now, this says for every world W prime, if we take T, That's the T above that. I can't get it. And apply it to W prime. And we take Q, apply it to W prime, and can join the result. Whenever that's true, Tully is famous in that world W prime. That is true. We pick some world W prime where Cicero is famous in W prime and Cicero is Tully in W prime. It follows that Tully is famous in W prime. So our De-Ray analysis gives us the opposite truth value for this sentence. It gives us something that's true. It gives us something true because the De-Ray analysis allows us to bring in an extra fact, a fact about the world that's not in Jane's head, but that is relevant for giving the translation of the sentence, Jane thinks that Tully is famous. Okay, I won't go through D, but it's in the textbook, and so you can go through it. It follows the same path as C.